Okay, I have the top of the hour, so it's time to get started. So welcome to the webinar called New Features of EKKO Project V6R2 GPR Software. I'm Greg Johnston. I'm with Sensors and Software, and I've been with them for plus 30, more than 30 years. And currently I'm a product manager. And so what this webinar is about is EKKO Project, and we released a new version last month. I think it was in early May, and that was V6R2. And so this is to go through some of the changes that we've added, some of the things we've added in V6R2. Okay, so the plan is to go through these items. I'm going to have a little bit of an introduction to EKKO Project. But then we'll get into some of the new features, auto gain, point interpretations in 3D, a new type of interpretation called map view interpretations, plotting interpretations in 3D, GIF animations, GeoTIFF files, augmented CSV files, and one called vertical merge. So these are the things I'm going to be going through. So if you do have questions, there will be time at the end for a Q&A session. But if you want, feel free to add something to the chat, add something to the Q&A section. We'll be checking both of those and get any inquiries answered. Okay, let's get started. So the catchphrase for the EKKO Project GPR software is visualize, understand, report. And that in a nutshell is what this software is for. GPR data is very visual data. There's many ways of plotting it and looking at it. So that's the visualization side of it. And then once you've visualized it, you need to understand it and add your interpretations to it, add your insights to it to tell the story that you see in the data. And then when you're finished that, the next step is you've got to report that. You want to report that to your audience or to your client. And so there's a whole aspect of output files from EKKO Project as well. PDF outputs, file outputs, visualizations, those sorts of things. So when I look at the changes, the big changes in EKKO Project, actually we're touching on all three of these things. We're adding some new visualizations, we're adding new ways to understand the data, and we're augmenting the reports that we currently have. And so let's look at that. So as I mentioned, there's several ways of displaying GPR data in EKKO Project. And the most basic GPR data is a single trace. And a trace is a recording of the signals that arrive at the GPR receiver after the GPR transmitter is fired, when the transmitter and receiver are located at one location. This is 1D data. A series of traces at different positions with equal spacing creates a GPR line, which is a 2D vertical cross-section of the surface, of the subsurface. When multiple GPR lines are collected to cover an area, they're either collected as a grid or as a pseudo-grid. They can be combined, processed, and plotted as a series of depth slices. And a depth slice is a 2D horizontal map of the subsurface. And the last way is 3D plots. So grids can also be plotted as 3D volumes or cubes, as shown on this image on the right. So EKKO Project provides all these types of plots. Now, the type of plot available to you depend on how the GPR data was collected in the field. So let's have a very brief look at the three basic types of data collection to set the stage for the EKKO Project software. The first type of GPR data collection is a line scan, as shown here. The GPR system is moved from point A to point B, and GPR traces are collected at equal intervals in between, generating a cross-section of the subsurface. The second type of GPR survey is a grid scan, where a gridded area is scanned with multiple parallel grid lines in the X direction or both in the X and Y direction. In this example, this gentleman is collecting a small 5-meter by 5-meter grid with a line spacing of about 25 centimeters, which is an appropriate grid line spacing based on the center frequency of the GPR antennas that he's using. In this case, it's 250 megahertz. So those antennas are 30 centimeters long. So a line spacing of 25 centimeters gives you a very good grid collection because you're getting full coverage over the area. So after you've collected a grid, they allow the GPR data to be processed into depth slices or in 3D. There's another way to collect GPR data over an area, and that's by combining a line scan and a grid scan together and collect what's called a pseudo grid by walking back and forth on one line scan. Pseudo grid, or I also call it random walk sometimes, that type of data collection relies on an accurate GPS for positioning. You need open skies to give you all the GNSS satellites so that you can accurately position the path of the GPR survey. If you do this type of survey in an area with limited open skies, like under tree canopy or around tall buildings, it will affect the data because it'll affect the positioning. It'll have things that are out of position, and that just makes it more difficult to interpret. So what you want to do is collect the data at a nice tight line spacing, like you're cutting your lawn. And when you collect data in a pseudo grid, it allows the GPR data to be processed into horizontal maps or depth slices. So when we open up the data that we've collected in EKKO Project, this is the screen you look at. And this gives you all the windows onto the data. So very brief tour of the data. So on the left-hand side, you've got a listing of all your GPR lines and grids. In this window here, this is a line preview of any line that you've currently selected. So it shows you the cross-sectional image. This is a map image of your survey site. You can see in this particular example, this was one of those pseudo grids where they walk back and forth, cover an area to create depth slices. And then one of the other windows in there is the layer view window. And the layer view window allows you to turn on and off different features in the data. For example, depth slices you can turn on and off, interpretations, the GPS path, flags, this sort of thing. Because it's very easy to clutter the image with a lot of different information, and therefore sometimes you want to turn things off to make your point and make a nicer image. So let's get into what the new features are in EKKO Project V6R2. And the first one is auto gain. Any GPR cross-section and GPR data in general needs to be gained. And the reason is that GPR signals, as they travel into the subsurface, they gradually get weaker and weaker because they're getting absorbed by the soil or the material that they're passing through. So it's almost always necessary to gain your GPR data to amplify those weaker signals at depth. And of course, you want to interpret the GPR data after it's been properly gained. But gaining is the very first thing that you end up doing with your data. And it can be tricky to do, especially if you're a novice, because really there's 3 parameters that you need to adjust. The amplification at the top of the section, the amplification in the middle, and the amplification at the end, at the bottom. And so now we've introduced a new feature called auto gain. But if you look at this image, there's 9, basically it is the same GPR cross section plotted with 9 different gains. So in the top left, you have a very low gain of 1, which we can see that is nowhere near enough gain. And in the bottom right, you have very high gain, which has amplified everything. And the signal, you can't differentiate the strong signals from the weak signals because everything's been amplified. And we know somewhere in the middle here, actually probably this image right in the middle, that's, one of these ones around here is the properly gained section, or at least a section that you can interpret the easiest. And what you want to see in a gain is you want to see all the signals. You want to differentiate which signals are strong reflectors and which ones are weak reflectors. And you also want to make sure that you see the background noise in the bottom, that as the GPR signal fades out, the only signal that's left is the background radio frequency noise. So this is a bit of a, it takes some practice to properly gain your data. And I've been teaching this for 30 years now. And it's one of the challenging things for people looking at GPR data for the first time. So I'm happy to say that EKKO Project now has a new and improved auto gain that automatically optimizes those 3 parameters I was talking about. So GPR cross sections always look their best and they're ready for interpretation. That's what you want to spend your time doing, interpreting the data, not tweaking the gain to try to get it perfect. So we did have an auto gain before, but it worked probably 50 or 60% of the time. But now we've been testing this new auto gain. It uses a new algorithm, and we've been testing it for about a year now, and it works about 99% of the time. You're going to have a very well-balanced section. Now, for those of you who who want control of the gain, we're not taking any of that away. You can go in, you can set up your own parameters for the gain. You can modify it any way that you want. It's just that it is going to default now to the auto gain. And if you don't want to use the auto gain, you can quickly turn that off. Now gaining data is also important for generating interpretable depth slices. So the new auto gain has also been added to the slice view lines feature, and that's the processing module used for processing pseudo grids into depth slices. Now, this is the dialog that you see when you open up slice view lines, and admittedly, it is a daunting dialog with lots of geophysical type settings that most users don't understand. Our geophysical customers like the flexibility to change these settings, but most users don't. And one of the settings that you have to set is the gain. And now we put the auto gain in there. So if you leave it at gain, if you leave it at the auto gain, and in fact, if you leave all the settings set to their default values and just go right into this menu and process the data, you are going to get good interpretable depth slices. So the biggest thing that improving the auto gain in slice view lines has done is made it that anyone can generate good looking depth slices 99% of the time. And that to me is an important step, because depth slices are very powerful ways of looking at your data and understanding your data. And so getting to them and getting to the interpretation is what you want to be doing. Okay, the next new feature in EKKO Project V6R2 are point interpretations in 3D. So let's talk about point interpretations for a second. There's several ways of adding point interpretations. The first way actually starts out in the field when you're collecting data. And this is a process where you're adding what we call field interpretations. And this is shown here. We've got 2 hyperbolas on the screen from 2 different objects. And the operator is putting a pink dot on the hyperbola on the left and changing the color and putting a blue dot on the hyperbola on the right. That is called adding field interpretations. So as you see, you do this by simply touching the screen at the location of the target of interest. So doing this in the field pays dividends later when we open the data in the EKKO Project software. So here's another example of collecting the data and adding point interpretations out in the field interpretation. So if you watch as he zigzags over top of this linear feature, which is a utility in this case, he keeps seeing the same hyperbola over and over again, same character, similar depth, And so he's adding a point interpretation to the top of it. And you notice you don't really have to stop. You could do it on the fly. You don't have to back up and be right on top of the hyperbola. You can just touch the screen where you see the hyperbola, and the GPS looks after all the positioning. Okay. In the end, once the data has been collected, watch what happens here. We come out of the data and we look at it in a plan view. And what you're going to see is, even though he zigzagged over top of that utility, all those pink interpretations line up to a straight line. And we've got a very good position of where that utility is running. Now, you can also add interpretations in the EKKO project software. So once you open up the data, you can look at the cross sections, and there's 4 different interpretations that can be added to cross sections. So the first one is the points. So we can add point interpretations in here as well. We can also add polylines, and polylines are lines that would go along the top of a reflector, bottom of ice, bottom of the lake, geological layer, soil layer, something like that. And they're called polylines because they can be broken up. They don't have to be one solid line. There can be multiple of them, but if there's an area where you can't interpret it, you may not put that interpretation in there and carry on where you see it. You can also draw boxes around areas of significant reflectors. And you can also add words. So annotations is also a type of interpretation. And so in this case, we have 9 cross sections that are all parallel to one another. And they each show 2 hyperbolas from 2 utilities that are in different depths. So the deeper one is marked with a yellow point interpretation, and the shallower one is marked with a green point interpretation. And what this new feature is that we can now take those interpretations and plot them in 3D. And so here's ones where we're looking at a series of dots, series of interpretations in 3D. And this is a static image, but in the software, you can spin it around and you can see the relative positions of each utility indicated by the colored points. And so let's have a look at that as an actual video. So this is sped up, so it's going to run through a couple times here. So the first step is adding interpretations to the hyperbolas. And in this case, there's a shallow hyperbola that they're marking with a blue dot. And then they create a new interpretation for the deeper hyperbola, and they mark that with a red dot. And in the end, they're going to take all those dots and plot them in 3D. So there they are on plan map. And then we save the CSV file. And after you save the CSV file, it'll ask you if you'd like to plot in 3D. So again, let's go through those steps again. First thing is to add interpretations. So we're going to create an interpretation for the shallow utility, mark them all with a blue interpretation. Then create another interpretation for the deeper utility. Mark that with a red dot. And then we'll see them in a plan map. And the cross section was a zigzag over top. So they zigzagged over these 2 utilities, and then we can plot it in 3D. Let's look at another example of this. Now, in this next example, there's going to be hundreds of interpretations, but we're only showing a few of them being added. So here's a cross section where the one type of hyperbola that they're seeing, they're marking with a blue interpretation, and the other type in green. And then when we plot it in 3D, these are all the interpretations, and there's hundreds of them there. And based on adding these hundreds of interpretations, you see patterns in the data, which is what you want. The green interpretations are actually, if you look at the data closely, they're ringing from metal, and so they're point objects. But some of the other hyperbolas that are marked appear as linear features, which end up being utilities. And so, again, great way of looking at your data, seeing the relative position and relative depth of the interpretations that you've added. Okay, let's talk about a new type of interpretation called a map view interpretation. So the previous interpretations that I've shown you are all for cross sections. You add them to cross-sectional images. Well, map view interpretations are for map views, as the name suggests. So EKKO Project V6R2 introduces a new type of interpretation called a map view interpretation. So as the user scrolls through depth slices, each one from a different depth in the survey area, they can draw lines called map view interpretations on top of linear responses they see in the depth slices. So on the left-hand side here there's actually 4 grids. If you look at these are 4 separate grids that were all collected over the same linear feature that's shown as this bright red spot here. So red being, in this case, high reflectivity. We're getting a strong reflection from a utility. Odds are it's a utility in the ground. And so they've drawn a gray line on top of it. So the gray dashed line that you see on top here was drawn by clicking and dragging across and putting that in the image. And that one corresponds with that particular depth slice. There's another map view interpretation here, and we don't actually see what it's drawn on top of. And the reason for that is it was drawn on a target at a different depth, on a different depth slice. But all those map view interpretations together are saved, and we can display those in 3D, as I'll show you in a minute here. Now, on the right-hand side, this is a GPR cross-section collected on a golf green. It's not cross-section, sorry. It's a depth slice from a golf green. And on a golf green, there's drainage. And so we're actually picking up the drainage pattern. The GPR is seeing the drainage pattern from underneath the green here. So somebody went in and drew the map view interpretations on where they think the drainage pipes are running in the golf green. So those are map view interpretations. And then let's look at the reality. Let's look at plotting those in 3D. And so we are now able to produce images like this, which take map view interpretations and show them in 3D. So let's go through that process. And I think I have 3 examples here. So if hopefully you can follow along. If you don't pick it up on the first one, you'll start to get it. So this one is GPR data collected on concrete. So it's a small grid. It's 4 feet by 4 feet, high frequency GPR. So what they're marking right now with the map view interpretations are the rebar in the concrete. And then as they slice down through, they're picking up other linear features, which would be, in this case, what are you expecting that would be linear underneath concrete? Well, they're probably conduits. They're probably pipes or utility conduits running through the section, running through the area. And then when you plot those, we can convert them to a 3D plot. And this is instantaneous now. As soon as you save any data to a CSV plot or to a CSV file, it asks you if you want to plot them in 3D. You don't have to, you can say no. But most of the time, you're probably going to pick that and have a quick look at your data. So again, drawing the lines, in this case, the depth slice, in this case, the rebar, then adding map view interpretations to the conduits running underneath. Some of them are curved. So you see that drawing the map view interpretation in segments rather than one continuous straight line. So if it's a curved object, you can draw it as a series of segments. And then at this step, when you save it as a CSV file, it asks if you want to look at it in 3D. And here we can see the conduits that are running underneath. So here's another example. This one is, if I can run this, hold on. How do I get out of laser pointer mode? Oh darn, hold on. Let's see if I can do this. Here we go. Okay, So in this case, we got depth slices on utilities. We're seeing there's a lot of reflectors in here in red, but there's only a few that are showing a linear reflection that are interpreted as utilities. And here we are, we drew the interpretations, the map view interpretations on them. We save it as a CSV file. It gives us the option to plot them in 3D. We take that option, and now we can look at it in 3D, and we can see the difference in depth between the top hyperbola, the shallower utility that was found, and the deeper utility that was found. So like other interpretations added to GPR data, the details of the XYZ coordinates of every interpretation can be extracted from the data and plotted. And so as you'll see, these XYZ plots are even more powerful if the GPR data was collected with GPS to position it in the world. Here's another example, last one of this, slicing down through an area where, and this was 20 feet by 27 feet, this area, and it's complex. It's got a very complex array of utilities here that we can see these linear features at different depths and in different orientations. And when you add map view interpretations to all of them and then plot them in 3D, we get a really good look of where they are with respect to one another. So again, this step is drawing the map view interpretations, slicing down deeper and drawing the ones that you see at different depth slices. Saving the CSV file, it asking you, do you want to plot it in 3D? Say yes, and there's your plot in 3 dimensions now. So that's actually my favorite new feature of the EKKO project software. I think it's going to get a lot of use. I think people are going to like using it because one of the things it does is if you can see the target that you're interested in a depth slice, you can draw it very quickly and you don't have to go through all those parallel cross sections and add individual points to the hyperbolas. So it speeds things up dramatically. Okay, the next feature are GIF animation files. And it's not exactly a new feature, but it's an improved feature. The last version of EKKO project had some issues with very large animations files. And so we fixed that up so that now we can create depth slices and GIF animations out of this. So you can scroll through depth slices as depth slices, as X lines or Y lines, and save them as a GIF animation file. And the nice thing about that is you can send, if the animation file tells the story of what you're trying to tell your client, it's a simple file to send to them. They can play it in virtually any software that's free. And so there's no expense involved in that. And so it makes a great deliverable for your client. Here's another example of a GIF animation. This one in an interesting setting. This is done around a tree. And so what you're looking at are the tree roots. And so this was 1,000 megahertz GPR data collected in concentric circles around a tree. So the center is the tree trunk, and all the data around it is slicing down at different depths and seeing the tree roots. So great GIF, also a great data set in my mind. Okay, new feature in EKKO project V6R2 is GeoTIFF files. Now you might be familiar with TIFF files. TIFF files are a graphics image format. So like a bitmap or a JPEG file, it's an image format. So a GeoTIFF, what it does is the geo suggests geography, and so the position of the image is embedded into the image. And so when you save your data as a GeoTIFF file, you have that the position of where the data is from embedded into it. And so this means that if you've collected your GPR data with GPS, you have the positioning for it. And when you create a depth slice, it has the positioning for that depth slice. And so the power of this is really when you have a GeoTIFF file, now you can take it into third-party software. And so one you might want to do is you can open GeoTIFF files in Google Earth. I didn't know that before we actually did that. I'm used to opening up KMZ files in Google Earth, but I didn't realize that Google Earth will also open GeoTIFF files. Now, so this shows a display of a GeoTIFF file in Google Earth. Now, it's not that exciting because we have had the ability to look at GPR data, depth slices, interpretations in Google Earth for quite a few years now. So there's nothing too dramatic there, but I just wanted to show you one place where GeoTIFF files can be used. The more interesting place to use GeoTIFF files is that any mapping software, and specifically GIS software, Geographical Information System software, like this, in this example, QGIS, Esri has software. Some of you are going to be familiar with GIS software. And so the nice thing is now when you're using your GIS software, you can open up a GeoTIFF file saved from EKKO project. So in this example, we've got a depth slice that's on here, and then we added a layer. So the depth slice is one layer, and then we've added another layer as the background roads. And so the roads and streets in the area here. We can also put in other images. GIS software has a lot of layering capability, as some of you are going to know a lot better than I do. But this is a nice place to use the GeoTIFF files that we can now generate with EKKO project. Now, EKKO project has always output CSV files for quite a few versions now. CSV, comma separated value files. People are more familiar with them as spreadsheets. It's a type of file that you open up in Excel and that sort of thing. And what we're opening up is the interpretations added to the data, as we saw before. So it's important to understand that adding interpretations to your GPR data is not just to create a pretty picture. Every interpretation has an X, Y, Z position, where Z is the depth of the interpretation. And if the GPR data was collected with GPS, every interpretation also has a latitude, longitude, UTM northing, UTM easting, elevation, all the information necessary to place the interpretation in the world coordinate system. And all this information is saved, it can be plotted. So this is really the information that your client or your audience wants to see. They don't necessarily want to see GPR data. They want to see what the GPR found. They want to know the position and the orientation of the objects that the GPR survey found. So adding interpretations to your GPR data allows you to extract that information that your client is really interested in and plot it. And so we have a setting, if you go in under the reports option, under the report options, one of the report types is a project report, which is a CSV output. And when you look at the CSV, we have columns and columns of information, the name of the interpretation, what line it was on, the name of the GPR line that it was on, the XYZ coordinates, the depth, the time, the amplitude of the GPR signal at that point, the velocity of the signal. All this information is available, and all this information is valuable when you want to take the data out into third-party software and display things. So this boring file, nobody really likes spreadsheet files. It's not that impressive to look at, but the results of it can be very impressive to look at. So let's look at some examples of exporting the CSV file and opening it in third-party software. So as I mentioned, we can readily take this into GIS software. So earlier you saw the depth slice from the GeoTIFF. Now we're actually looking at the points from an interpreted utilities. And the beauty there is that you can color coordinate it, so you can vary the color based on depth and all sorts of things in there. Another place you can take CSV data and open it up is Surfer. So Surfer is a visualization software by Golden Software. And so here is a Surfer plot of a GPR depth slice, and it's plotted in kind of this 3D sort of plot, which we don't do this in EKKO Project. We certainly do depth slices, but we do that by variable colors. But in this case, you're actually plotting it in Surfer with one of their outputs for a surface. Now, speaking of surfaces, if you think about it, if you take all the points from interpretations on, say, a surface in the data, so if you've done, like this example is bathymetry. So somebody went around a lake with a GPR and a GPS, and now they've extracted all the points from the reflection from the bottom of the lake, and now they're plotting that surface in the Surfer software program. And so in this case, we can see the surface that, going from shallow at the shoreline to deeper in the middle of the lake. And it turns out in this particular lake, there's an interesting pinnacle there. It must be bedrock sticking up between or something like that. So again, this is from data. This is from GPR data, the information extracted from GPR data, but plotted in third-party software. Another example is plotting, taking the CSV file and plotting it in, point cloud software. That's the word I'm trying to think of. Point cloud software will allow you to plot any columns of CSV of a CSV file. And in this case, we have hundreds of interpretations added to GPR data plotted in 3D. So it's similar to what we've just introduced, but now it's being done in third-party software, in this case, point cloud software. Also in point cloud software, we can output CSV files of X, Y, Z, and amplitude. And if you take all that, you can plot a three-dimensional cube. And so what varies in the cube is the signal strength, the strength of the reflection. And then in software like Point Cloud, you can remove the weaker reflectors and only show the very strongest ones, like we're showing here. So that's how you've seen these two utilities kind of melt out of the cube, by removing all the weaker reflectors and only leaving the strongest reflections. Terrific way of looking at your GPR data. Okay, the last new feature that I want to talk about is one called vertical merge. And this is an interesting one, and I'm interested to see the reaction and see if people use this. So you know that GPR cross sections, you know that frequency is very important for resolution. If you collect data with a high frequency antenna, you're expecting to see high resolution of small objects, but you know they're going to be shallow. You can't see to 10 meters with 1,000 megahertz. It would be nice if you could, but you can't in the vast majority of cases. Maybe ice, you might be able to see 10 meters at 1,000 megahertz, but you're certainly not going to see 10 meters in concrete. You're not going to see 10 meters in clay or any typical soil at 1,000 megahertz. So when you do image with 1,000 megahertz, you're looking shallow. And so then if we collect data on the same cross section or the same line with a lower frequency, you know we're going to see deeper. And so at 250 megahertz, we can see that the signals are traveling deeper. And then at 50 megahertz, and even lower frequency, the signals are traveling even deeper. And so what the vertical merge allows you to do is take sections of each GPR cross section and blend them together into one. And so, for example, in this case, we're going to take the first 1.5 meters of the 500 megahertz. I said 1,000 megahertz. This should have been 500 megahertz, beg your pardon. At 500 megahertz, we're going to take the first 1.5 meters, and then from 1.5 meters down to 4 meters, we're going to use the data from the 250 megahertz line. And then from 4 meters down to 10 meters, we're going to use the data from the 50 megahertz line. And this is very easy to set up. You just bring in your 3 lines. You say, okay, I want this depth range on this frequency, this depth range on this frequency. And in the end, you get a plot like this. And so we have, and it's hard to look at. You have to look at the resolution of the very high frequency, the 500 megahertz. You kind of need to zoom in and see all the details. At this scale, you can't really see it very well, but it's there. And so from 0 to 1.5 meters, we have 500 megahertz data. And then from 1.5 to 4 meters, we have 250 megahertz data. And then from 4 meters, actually to 13 meters in this case, I was mistaken. From right down to the bottom, we have 50 megahertz data. So an interesting plot, basically taking all your interpretations or taking all the cross sections, taking the information from 3 cross sections and combining them into one. Okay, so those are some of the new features of, these are certainly the biggest and brightest new features of EKKO Project V6 R2. And here's a list of them again. And so we've hit the point now where I'm ready for questions. So we have, let me have a look here in the question and answer. When you're drawing linear interpretations to plot in 3D, do you have suggestions on how to draw wider features? For example, if you have a large conduit tunnel, pipe or tunnel, or a thick wall, I would draw parallel lines. And so I think one of the examples kind of showed the concept. I would draw lines very close together so that you have a mass of points in the end. And it's not exactly the same, but if I go back to one of the earlier ones, I think it was this one here. If you play this one, I'll try to pause this if I can. No, I gotta get out of this mode. No, I can't figure out how to pause the animation here. There is a section there. You can see there's a bunch, there's 5 utilities all together. Now they're at different depths, but if you had the case where you had something that was very wide, I would just draw a bunch of them side by side by side. And then when you started to look at them in 3D, you would actually see them. The other thing you can do when you get into the 3D software, you can actually vary the size of the point. So there is a setting in there for the size of the dot. So that might be another way of making it kind of look larger if that's what you're after. Okay, those are my 2 best suggestions on that. I'm going to answer a question that nobody has asked because somebody, the last time I did this webinar earlier today, somebody did ask. And that was map view interpretations for a sloping utility. If it's, how do you handle that? And it's not ideal, but it works. What you can do is draw segments on each depth slice. So you understand that if you have a sloping target in the subsurface, your depth slice is going to go through it multiple times. You're going to see one section of it in a shallow depth slice. And then as you go down deeper, you'll see the next section of it that's a bit deeper down, and then the next section a bit deeper down. And so what you're going to do is just draw short segments of map view interpretations on each depth slice. And then in the end, when you look at it in 3D, it's going to look a little bit like stair steps, but it will get the point across that this is a sloping feature. Okay, what else have we got going on here? Any word on exporting 3D seg-y cube for import into other software? I am sure that the first thing I would do is see if you could plot the CSV file in your third-party software. Does it definitely have to be seg-y is my question. If it doesn't have to be seg-y, see if you can read it in as a CSV. And it's just the simplest format there is, which is X, Y, Z, and amplitude. And so that would be my point on there. So to answer your question, technically, no, we don't have a 3D seg-y output. That's something I will put on the list for hopefully a future version of EKKO project. But in the meantime, I think there's got to be a way to get your data out there. Now, you can save the GPR cross sections to a seg-y file, and I'm not sure whether you can take multiple seg-y files and bring them into that software. That would be a question. That would be something for you to try. And actually, if you're successful, can you let me know? Because I would be curious about that. It would be nice to know if there's a feature that, if there's a capability that we don't realize that we have. Okay, I'm going to bring up the last slide, which has an email address on it. So if you do have any inquiries either later or maybe after you watch the recording of this, feel free to send an email to this email address and it will get to a person who can answer that. So enjoy the rest of your day. Thank you very much for attending.